All right. This is the homework tonight, and here are the answers to last night's homework. Let me scroll up. Go ahead and pause this and check. I'll scroll up a little bit more so you can see the bottom. Now, if you're watching this from home, we're going to do a graphing calculator lesson today, learning how to take a table of values and find an appropriate equation. We did that last night by hand, whether they were linear, quadratic, or exponential. But we're going to do it on our graphing calculators today. If you are not on page 602 in your book, we want to get to page 602. We are going to do numbers 19 to 21 together. And to be perfectly honest, this lesson is more of an FYI lesson for your information than something that I am really concerned about you knowing about this year. Now, you are going to want to jot down some notes because there are some things that I'm going to do with the graphing calculators that if you don't write them down, there's no way you're going to remember them. So, I'm going to bring my graphing calculator to the forefront up here. The first thing I'm going to do is just clear my memory. I want to get it back to factory settings. I don't want anything in there. Now, we are going to do what is called linear regression. And we actually did this earlier this year. But it was really a very brief lesson, kind of like today is going to be. The first thing you need to do is turn your diagnostic on. Now, diagnostic, you see down here above the 0 where it says catalog. You're going to hit second catalog. And this gives you a whole list of features on this calculator. And they're in alphabetical order. D is located above, look where I'm circling. See the D? If I hit that, it's going to take me down to D on the list. Or you can just scroll down to D. Diagnostic. So I'm going to scroll down. Until I see diagnostic on. And then I'm going to hit enter. Turn it on. Hit enter again and it will say done. You must have your diagnostic on to be able to do linear regression or quadratic regression or exponential regression. And this is the step that people forget. All right. Now, when you are doing a problem from a table, we are going to enter the values from number 19. To get to the table, you are going to hit, do you see stat button right here? Look where I'm circling. Hit stat, and you are going to edit. So hit 1. Now, this gives you the beginning of a table. We have a 2-value table. So we're in the first column. The values in number 19 are going to be 0, enter, 1, enter, 2, enter, and 3, enter. All I'm doing right now is entering the values from number 19. Now I'm going to use my over arrow to enter the matching Y values. And we've got 1.7, 1.7, enter. 1 is paired with 1.4, 1.4, enter. 2 is paired with 4.7, enter. And 3 is paired with what? 7.9, enter. Okay, now, we first need to determine, using our calculators, if these particular values are closer to linear, closer to quadratic, or closer to exponential. And to be honest, with those values, graphing it, it would be nearly impossible to tell. And the calculator is going to help us determine which one is best. Now, what we are going to do, go back to your stat menu and over to calculate. Okay. I'm going to write this on the board. Stat over to calculate. Then we want to do linear regression, quadratic regression, and exponential regression. And what we are looking for is the one that has the highest R squared value. And you'll see what I mean in a moment. Because the R squared value, the highest one, if it's linear, then this is line-like. If the R squared value is highest in the quadratic regression, then it is closest to a quadratic function. If the R squared value is highest in the exponential regression, then it would be closest to exponential. And then we're going to use the calculator to write the equation. So the first thing we're going to do you see linear regression is number 4? I'm just going to do that first. So I'm going to hit 4, and I'm going to hit enter. Enter. Keep hitting enter until it gives you your values. Now, the R squared value for linear regression is 0.864849. I'm going to go to 4 decimal places. Okay, I'm writing that down because there's no way you're going to remember that. So I wrote it down. 0.8648. You don't care about anything else at this point. 49, yes, sorry, I rounded wrong. You don't care about anything else right now. You're trying to figure out which one of these regressions is best. So go back to stat and over to calculate. We just did linear regression. Do you see number 5 is quadratic regression? Go down to quadratic, hit enter, or you could have just hit 5. And again, list 1, list 2, enter, enter, calculate. Now, the R squared value for this quadratic is 0.9753. Well, we know that quadratic is better than linear already. But now we need to check exponential. So we're going to do the same thing again. Stat, go over to calculate. Now, you've got to scroll down. We are looking for exponential regression. It's 0. Enter, 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 enter. Calculate. Okay. The R squared value. Are you doing how to do this? For exponential is 0.8299. So, which one has the highest R squared value? Quadratic. So we've now determined that this list of points is closest to a quadratic equation. What would its graph be closest to? What would it look like? It would look like a parabola. Okay? So, go back to quadratic regression because now we're going to write the equation. By the way, are you noticing right here? Look, the equation is a times b to the x power for exponential. We know that. In linear, it was a, b, or ax plus b, which is mx plus b, but they use a. And let's go back to quadratic. So stat, calculate. Quadratic is 5. Enter, 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 enter. Here we go. Now, there we go. Take a look at that. They're telling you right here on the screen that the equation for a quadratic is y equals ax squared plus bx plus c. Correct? There's a, there's b, there's c. So your equation taken directly from the calculator is y equals a, which is 0.875 x squared, plus b, but look, that's a minus. Do you see the negative there? Minus 0.435x plus c, plus 1.515. There is the equation of the quadratic represented by that table of values. Yes. R squared, remember earlier this year when we did linear regression? Linear regression, the R value is between -1 and 1. The closer it was to 1, the tighter fit to a straight line. The closer to 0, the data was scattered all over the place. So same thing with this. The higher the R squared value, the closer the data is to whatever expression you're looking for. So the closer it is to a line, or the closer it is to a parabola, or the closer it is to an exponential curve. So none of this data is perfect. But in this set, it is most like a quadratic function. And that would be the equation that would model it most closely. Okay? The closer it is to 1, the better fit it is to whatever the graph is you're doing. And is it 1 squared 1? So, yeah. Yeah. I think if you have a set of data that is perfect, it might be, but it's probably not ever going to be close. I mean, especially if you're using it for real life data. All right. Let me hit pause on this. You guys right now are going to do number 20 and 21.